in the meshing step, we will divide the domain into nodes and elements. And in the process, we are going to mark out the selected locations at which we want the ansys solver to calculate the temperatures. Go to the project page and double-click on model. This brings up ansys mechanical. After a little bit of hesitation, ansys mechanical comes up, so we can specify the mesh here, and we can also specify boundary conditions and so on. So let's go to, let's highlight mesh. And I usually like to throw a default mesh on it. Sometimes it doesn't work for very complex geometries, but usually it works. And then tweak that default mesh to get a more suitable mesh. So highlight mesh and say update. And that gives me the default mesh. And I'm going to turn off the triad here so I can. Okay, and I can turn off the ruler if I want under view. I'll keep the ruler for now. And I see a little bit of jaggedness in these lines. I'm not sure, if I zoom in here using the right mouse button, I'm not sure if this is an artifact of the graphics display, or it's actually a little bit, it's not exactly horizontal. And for regular geometry, you can ask it to give you a regular mesh, and you do that by putting in mesh control and say face meshing. This used to be called map face mesh in previous versions. It's the same thing. And I'm going to, so I need to have the face selection filter selected so that I can select in this face or area, and then come here and say apply. And let me zoom out here. Okay, and if I look and then I say update the mesh, and that seems more regular. And face meshing will work, only for simpler geometries. And if you have something a little bit more complicated, you can give it some guidance, on trying to get a regular mesh. And I also want to control the number of elements that I want. And I'll say I want 4 elements along there and 8 elements along there. Essentially, I want each element, each edge length to be 0.25 meters. So I'll go to mesh control and I'll say sizing. And I can scope the sizing to, I can put the sizing on lines, I can put it on areas, I'll put it on areas. So I'll click on that and say apply. And for element size, I will say 0.25 meters and double check your units here. And if you need to change the units, this is where you change it. And then update the mesh. That didn't seem to change anything. That's because in the face sizing, I have a soft setting, and the solver just took it, or the mesher just took it as, as guidance. And this is what you typically do when you have complex geometries. You can just give it some guidance on what kind of size, and then it'll adjust it according to the geometry. But for simple geometries, we want to tell the mesher, hey, don't mess with my setting. Take it as a hard setting. So I'll take that as a hard setting, and then I will update the mesh. And if I go and look at the mesh, now I see I have 4 elements along here. So it's imposed that that sizing that I gave it over here. But when I turned on the hard setting, and I have 8 elements along here. And here I have 2 messages. So if I click on that, and I can click on these warnings, and it's good to take warnings seriously, otherwise they can come back to bite you in uncomfortable places. And if I double click on it, it says some element sizes are larger than the global maximum size. That's because I have this advanced size function selected. So if I go under sizing, mesh sizing, and I see the advanced size function is turned on, and and it has some maximum size over here that is being violated by our sizing. And again, advanced size function, you want it for complex geometry. For simple geometries, you can just turn it off. So when I turn it off and I update the mesh, I'll see I don't get the warning anymore. So now we have the mesh that we need, and let's next consider the number of algebraic equations that we have told the solver to generate.